Hey y'all, I think this is 1520 example or homework. Can't recall from my notes. But we have a mass on rollers, so we're assuming we're frictionless under here. And it's got a force that is a function of time, 20 times t plus 1. And it's pulled up at an angle of 30. One of the first things we should do is to check whether mass times gravity is greater or less than the component being pulled up, and in this case it shows that it will not leave the surface, so we can ignore it for now as long as the applied force is less than the weight. It will not leave the surface. It does have an initial velocity of 20 meters per second also. Something else that you should do anytime you see a function of time or position is see what happens at time is equal to 0 or x is equal to 0. In this case, putting in 0 for time gives me 20 times 0 plus 1. So at the instant we're considering this motion, there is 20 newtons being applied, and as time goes on, this becomes 2 and then 3 and then 4 and so on. It is going to be a greater and greater force. Okay. So let's conserve linear momentum. So we can say L1, L1, and this is just in the x direction. Let's leave the vector signs off for now. But L1 plus our impulse is equal to some new L2. And we can get this impulse as the integral of f in the x direction and we use the x direction because that is where the motion is occurring and it's not moving up or down. So use the force that's applied or the component of the force in the x direction, in this case f cosine 30. And we do have some initial momentum, some mass times v1, and that's going to give us some new momentum, mass times v2. We know what the force is. It is 20 t plus 20 is easier to integrate if you expand it, for me at least. We know what the mass and the velocity are. We have a 200 times a 20 right here, and we don't know what this final velocity is, but we know the mass, and it is 200 kilograms times v2, we'll call it. Alright, integrating. Well, first of all, I guess the most important part would be I was going to do this in 2 steps, but we really need to put the cosine of 30 degrees here, and I almost forgot my integration variable. And that's going to be some 200 times our final velocity. And we can integrate, evaluate. Cosine is not a function of t, it's just a number. The angle it's getting pulled at never changes. So we're just evaluating with respect to t, and it wants to know after 5 seconds. Alright, crank that number out, and you have your answer.